Hello, it's 6 a.m. I haven't slept, and I'm finally recording the episode for yesterday. So, the first problem. We have a composition that is the direct sum of E1 and E2. Have to show that in each class of E with respect to E1 is equally 1 vector of E2. Let's begin by writing down the general form of the call set. That's gonna be A plus B in the set. Next, we're going to specify that A belongs to E1, and outside of the set, we're going to specify that B belongs to E. So for every B that belongs to E, this set is going to be the relevant call set. Now let's review different cases of what B could possibly entail. So let's begin with a simple deviation. Let's say that we have a B belongs to E1 and B does not belong to E1. This kind of branching. So it does not belong and belongs here. So if B happens to belong to E1, that would imply that A plus B also belongs to E1, and A plus B will be belonging to E2 only if A plus B equals 0, because the intersection of E1 and E2 is 0. So essentially we can say that A is equal to the inverse of B. Okay, next situation, B does not belong to E. We have again two branches. B does not belong to E2 and B belongs to E2. Now if B belongs to E2, then what we're doing is we're adding to an element that belongs to E2 an element that does not belong to E2, so A plus B for sure does not belong to E2. Now in the other case, it's far more ambiguous, but we can write down B as a sum of elements that belongs to E1 and element that belongs to E2, because mind you, A is a direct composition of E1 and E2. Okay, now let's perform the sum. We have x plus A plus y, and this thing will belong to E2 only if x plus A equals 0. Again, for some more reasons here. So x equals negative A equals a negative x. So we have deduced that for different cases, we have this two branches. If B belongs to E1, then the relevant element where A plus B will be part of E2 is A equals negative B. Next, if B is not equal to E1, and if B is not equal to E2, the relevant element will be A equals minus x. And for the final part, what we have here is if B is equal to E2, and now I did kind of fuck up here. I said that A does not belong to E2, which is a lie because A could also be equal to 0. So for A equals 0, A plus B belongs to E2 here. So for every single case, there's some elements here that would be part of A2. So let's continue now. E1 and E2 as subspaces of E. I have to show that the sum is a linear closure of the union. And we also have a bunch of other proofs. Let's begin with the first one. Now, since it's the union, we can say that it is going to be for every vector x, it is going to be the sum I, let's take beta I xi plus, let's say, gamma I y I here, or let's take a different letter for diversity sake, let's take j. Now, thing is, I have done there is I have said that every vector in the union can be represented as a linear combination of vectors relevant to E1 and vectors relevant to E2. Here, xi belongs to E1. Here, xj belongs to E2. So now the thing is, we have essentially just written down two vectors that are linear combinations, not A, just like separate linear combinations inside of different subspaces. So this is gonna be some vector that belongs to E1. Let's call it P. Let's call this one Q. So x equals P plus Q. P belongs to E1. Q belongs to E2. Cool. Now the rest, we have to prove that if the sum equals to the union, then one of the subspaces is supposed to be a subset of another. So let's go ahead and do that. Now, when would it be like that? You have to show that we were to say that E1 is not a subset of E2, and E2 is not a subset of E1. Implies there's element C that belongs to E1, but C does not belong to E2, or vice versa. There's symmetry, so I only really have to prove one of the cases. So let's go ahead and use this to our advantage. We have just said that E1 plus E2 is equal to E1 plus, not plus, union with E2. Now, thing is, we were to take this element C, it belongs to E1 but does not belong to E2, and we add it to E2, then the result is supposed to neither belong to E1 nor E2. And thing is, well, this doesn't make sense because, as we have already stated, the sum is supposed to be the union of E1 and E2. And well, every element inside of the union will be part of either E1 or E2. So this is proof for a contradiction. That's it for today. I'm really tired. I'm so sorry. It's 6 AM. I'm absolutely devastated. I haven't slept. Bye.